Let's look at another polar equation and let's graph it. R equals 4 sine 2 theta. We begin with trying to test for symmetry. So let's look at some symmetry that we have first of all. So let's test for the polar axis. Where we change theta for negative theta. And that becomes, remember sine is a odd function. So R equals negative 4 sine of 2 theta. And that does not produce the original equation, so it's not symmetrical about the polar axis. This time, let's go ahead and switch and test for the vertical axis. Again, we can bring the negative out, and so I have negative r equals negative 4 sine of 2 theta. Multiply both sides through by a negative. And that is my original equation, so we do have symmetry about the vertical axis. Let's check the origin. Solve for r. And we notice that that does not produce original equation, so there's no symmetry about the origin. All right, let's begin graphing this. As we continue to look at these, look at this and graph it, I went ahead and graphed and chose some points between 0 and pi and found their corresponding values. So that's enough to allow me to graph it. I think I have a scale of 1 to 4, 1, 2, 3, 4. So let me go ahead and start graphing this. In the 2/3 pi direction, I go backwards. On the first quadrant, and the second quadrant, I have what looks like to be a part of a flower. I got a couple of petals here. Now I know that this was symmetrical about the vertical axis. So that being the case, then I can just reflect this about the vertical axis. Now notice that this graph, although it passed the vertical or the symmetry test about the y-axis, we can see that it reveals symmetry about both the polar axis and the pole. So although it failed those two, we see that it was symmetrical about that. But let's explore this idea a little bit more too. Let's see what we have going on here, because this starts to open up another type of pattern that we'll see. So what we have here is something called a rose petal with 4 petals. Now we can confirm where the angle is that produces the peak of those petals, or petal points. And we do that when we know we have a maximum radius of 4 or negative 4. So let's go ahead and solve our equations then. So 1 is 4 equals, which is my function. Divide both sides by 4. Where is the sign equal to 1? That occurs when, one place it occurs at is pi halves. So then I know that 2 theta equals pi halves. And where else does it occur at? Plus 2 pi past that. Or every 2 pi beyond that, so 2 pi in. Solving for theta, divide both sides by 2. And so I know that this is true at theta equals pi fourths plus n over pi. And then, so if n was 0, I have 1 petal point at n, or pi fourths is n equals 1. I have 1 at pi fourths plus pi, which is 5/4 pi. We also know that this is true when I have a value of negative 4. Structures way down to be very similar all the way through. 5 by 4. Where do I have a sine of theta equaling negative 1? That occurs at 3/2 pi. The 2 theta equals 3/2 pi plus every pi past that, or every 2 pi past that. Solve that for theta equals 3/4 plus n pi. So at n equals 0 in this case, or n equals 0, that's 3/4 pi. And that n equals 1, that's 3/4 pi plus another pi, which is 4/4, gives 7/4 pi. So I have 4 points on this graph where the maximum distance, or the distance from the origin, is 4 units away. And the angles that correspond to that are pi-4ths, 5/4 pi. So here's pi-4ths. Here's the other one at 5/4 pi, 3/4 pi, and then it's 7/4 pi. And what those are what we call the petal points of this particular graphical, graph. So let's show off our family of rose curves, or propeller blades. Now, a couple things I want you to be aware of is that all these graphs follow these basic form of r equals a sine of n theta, or r equals a cosine of n theta. 2 things to notice about these is notice what happens when n is even or when n is odd. On the first one that has 4 blade fans, it's r equals a sine of 2 theta. 2 in that particular case, which represents our n, is an even number. So when you see an even number, the amount of propeller blades that we'll have, or the amount of rose petals, will be twice that many. Likewise over here on r equals a cosine of 4 theta. 4 is even, so therefore I'm going to expect to have 8 propeller blades. And then the other 2 represent odd, or functions that have an odd angle or odd double angle in it, 5 and 3. And because n is odd, we'll have exactly that many propeller blades or rose petals. So r equals a cosine of 3 theta. 3 is odd. I will expect in my graph to have 3 petals, or 3 propeller blades, or whatever else that you may want to choose. So anyway, this is an introduction to the family of rose curves.